Hello class, this is Dr. Mike with a few minutes of Linux for you. So real quickly, I want to talk about links for this week. So links themselves, what are they? So before we get into the details of the command and of course how to view a link, what is a link itself and what flavors does it come in? So what we have two types of links in Linux. There's something called a soft link and a hard link. Links are really shortcuts. So soft links, which you'll probably end up using the most, I have used the most, is really just a shortcut to a file or location. So no difference than creating a shortcut on your desktop in Windows to a location somewhere in my documents. We can do this with Linux, and it's very handy if you deal with a lot of deep directories and you need to move stuff back and forth every day. It's nice to have a short link, soft link for that shortcut. And of course, the file itself does go to an inode. We'll talk about iNodes in a second. Now, a hard link. What's the difference? So hard link is a straight shortcut to the inode itself. And you think to yourself, well, what's the difference between the two? Hard links are really going to be used more for system level use. I have an application that needs to process. I can control how it processes based on links I can set up for it. Hard links have some rules. They cannot span over partitions. And normally you don't have users themselves making hard links. This is something sysadmin might do. And to be honest, it's very rare. I actually did this. And usually if I installed applications that needed them, they will actually set them up themselves. So understand there's hard links and there's soft links. Soft links can span systems. But again, everything points to the inode. So let's give you just a real quick thing. What is an inode? Inode itself, so here we have a name and an inode, so a directory entry. So an inode itself, inode is a block on disk that contains information about everything from the access time, the file size, the user ID, group ID, of access, who owns it, and it has pointers to the file content. As you probably know, files are not typically stored contiguous; they are usually fragmented. So this will have points to the very first part of the file, and of course block 2 if it has several blocks. And even has indirect blocks where it could be not accessible from the same blockchain. So anyway, the file content. So we have access. This is part of the inode itself, and it's very important. So iNodes, there are limits for iNodes. Let's look at that. So df-h, we can see, gives us, again, our use, 3% used. We have available 3.2 terabytes here on dev SDA2, 3 out of the 3.5 terabytes. So probably the most common way to, of course, check your directory use is with df-h, but you can do df-i, and we can see inode use. Again, number of inodes will change by system. There's a system level maximum, but it's going to change by system. But df-i is going to give you the number of inodes and number used. Now, it's pretty rare, but it is possible. I don't think I've ever seen it, but it is possible. I could create more files, more inodes. So let's say, death by 1,000 stings per se. Instead of having 10 large files that takes up all 3.5 terabytes, I have a lot of tiny files that take up all my inodes. Now, again, that's a pretty rare condition, but it is possible, but again, very rare. But you can check that with a df-i. So let's talk about making links. So I'm just going to focus real quick on soft links. So if I look at ls-l at my test directory again, I created a link here. A link is denoted by an L with the first character of the ls-l output. You can see I have a link called temp stuff that goes to temp in a file called stuff. So it's like a temp. There's a file there, empty, but it's called stuff. So how can this be handy? So let's say I am constantly running scripts and I'm creating output. let's say I'm going to do ls-l. I'm going to output this to a special directory on a different part of the system, but for now we'll do a full path. Sysadmin, test, temp, output, ls.txt, let's say. Those can become cumbersome, even with the nice shortcuts of the bash shell. Let's say this is really long. I've worked in places where this could be very long, very, very deep long directory path. So if I want to, let's say I want to create a shortcut. So I do ln, the link command. And it's important to don't use the S for soft link. So the original file is going to be, or let's say the original directory is going to be, again, home. I'll do a full path here. Temp, output. And I want to call this outdir. Again, it's the ln space -s. This means soft link. Where I want this link to, the original location of the link itself. And then what I'm going to call it. I'm going to call it outdir. Now if I do ls-l, you can see I have this outdir. Now I can go ahead and run my command, but instead of doing this, I can just say, hey, send this to outdir and call it ls2.txt. You can see I actually saw the other file. So now I can quickly get to this location with one quick link. I've used this a few times. Usually when I worked in data processing, would pull system logs and have to put them out to a web directory to be processed, and it had a very long path, and it was something we would run manually as part of the job. So having a short link like this, I think mine was called web out, in fact. And so it was a very easy, very nice way to go ahead and just have that in place. If you make scripts around that, just be careful that if the link gets broken, it could break scripts, but that's what normal system administration is about, so making sure things run as they should. So in case, hard links, soft links, very, very handy. You know how to make them, and the lab will show you how to make them and break them and such. So hope this is helpful.